Okay, good morning class, right? Okay, first of all, I want to say thank you, right, for spending your holiday, okay, to attend my class today, okay. Actually, I just want to finish chapter 1, right, because we already, if we didn't do class for today, right, so we already missed 2 classes, okay. And for M and for K, they already finished chapter 1, okay. So let's start our lesson. Okay, I think we stop until here, right? Alright, for those who still didn't get the notes for chapter 1 and tutorial, I'm really sorry. Okay, because actually I already sent to school for photocopy, right? But they lost the master copy. So mean this week I have to send it again, okay? And I try my best so you can get the notes, okay, by this week. Okay, and already I also will give you the chapter 2 notes, right? 2.1 and 2.2. Okay. Right, so let's start our lesson. Okay, I think we stop until here, right? This one I think I already finished. Okay, so we stop until here. Okay, so type of graph. Okay, so this is the straight line graph. Okay, straight line graph. Okay, and then is it pass through the origin here? Okay, you can see it's not pass through the origin. If pass through the origin, it will come from 0, 0 like this. Okay, so through origin, no. Okay, so how about the gradient? Okay, so I think you already learned on form 3, right? If the graph line is increasing like this, it's a positive gradient. Okay, positive gradient. But if the graph is decreasing like this, okay, this is a negative gradient. Okay, so the gradient here is negative. Okay, so after this, we will try to calculate the gradient, right? I will give you one example. Okay, and interpret the graph. So if the graph like this is y is decreasing linearly with x. Okay, decreasing linearly means it's straight line here. Okay, so let's say if I have an example like this. Okay, let's say here is G and this one is okay. So let's say this is the example here. Okay, and the value here is 0, 10. Okay, and let's say this one the value here is 5, 5. Okay, so let's say this is the coordinate. Okay, so the first one you have to find the gradient. Okay, so remember I said before in physics, if we mention about the gradient, we must have a triangle. Okay, so you must have a triangle. So I said take 2 points. Okay, so I take this point and also this one. Then I just underline here, so it will form a triangle like this. Okay, so how you want to find the gradient? You already know y2 minus y1 divided by x2 minus x1. Okay, can someone try to calculate the gradient and give me the answer in chat? Try to calculate the gradient. Negative 1. Negative 1. Okay, so let's say this is xy, y1, x2, y2. Okay, so 5 minus 10, okay, divide by 5 minus 0. So you negative 5 divide by 5, right? So you will get negative 1. So here we already proved that the gradient is a negative value. So what if I want to make equation from it? Y is mx plus 6. So can anyone try to make an equation? We already calculate the gradient here. Okay, try to make an equation based on the equation, the general equation for the straight line. What is the equation? M is T plus T is M plus 10. Okay, so let's see is it true or not. Okay, so what is the title of y-axis? So the title here is T. Okay, okay, and then the M is the gradient, so we already calculate negative 1. Okay, and then the X here is M. Okay, so negative 1M plus, okay, C is actually the y-intercept, right? So the y-intercept is 10. Okay, so if I simplify it, so you get negative M plus 10. Okay, so negative M plus 10. You must put the negative sign. Okay, because the gradient here, the value is negative. Okay, they say if 1, then it's okay. Just put M here. But since it's negative, you have to put the negative signs here. Okay, so this is the equation. Okay, the first one, you calculate the gradient. The second one, you form the equation. Okay, and then number 3, so let's say asking you to interpret the graph or asking you to find the relationship between T and M. Okay, so the graph is decreasing linearly, right? So T is decreasing linearly with M. Okay, so this is the answer. So this is the example. Okay, the questions. Okay, how they ask you if the question come up. Okay, in the exam, right? Right. So next part. Okay, so I already told you for physics, we only have a straight line graph. Okay, so there is no curve graph. But for the relationship, we have to know for the curve graph. But for analysis, like find the gradient or equation, you don't need to know for the curve graph. Okay, only the relationship that you have to know. Okay, so you can see here the line is a curved line. Okay, it's a curved line. Okay, is it pass through the origin? Yes, you can see it's pass through the origin. So yes. Okay, so the gradient here you can see the value is increasing, right? So it's it's a positive. Okay, the gradient is positive. So how you want to interpret the graph? Okay, so y is increasing with x. Okay, so y is increasing with x, right? Okay, so far any question you want to ask, teacher, about these two graph? If you have any question, you can ask in the chat. Anything, any part that you are still not clear? Because this one is very important for your paper 3. Okay, right. So no response means I just think that you understand. Okay. Alright, for this one, so this one is also curve. Okay, curve line. Okay, and it's not pass through the origin. Okay, you can see it's pass through the y-axis here. Okay, so pass through the origin, no. Okay, and then the gradient you can see is decreasing, right? So the gradient is negative. Okay, so how you want to interpret the graph? Y is decreasing, okay, with x. Okay, y is decreasing with x, right? So line is curved, pass through the origin, no. Okay, since the y is decreasing, so the gradient is negative. Okay, and y is decreasing with x. That one is the relationship of the graph. Okay, so how about this one? So it's different from this one because this one you can see it intercept the y-axis, right? But for this one, it doesn't intercept the y-axis. So the type of graph is a curved line. So I put here is a A, okay, and this one is T. Okay, so for A, the type of graph is a curved graph. Okay, but for B, it's a straight line graph. Okay, straight line graph. Okay, and then how to interpret the graph? Okay, so for A, this one is y is inversely proportional with x. Okay, so it's different from this one. Okay, for this one, because it intercepts the y-axis, we call it as a y is decreasing with x. Okay, but for this one, because it doesn't intercept the y-axis, okay, so y is inversely proportional with x. Okay, but however, if we change the x-axis, so let's say this graph, okay, and you change the x to 1 over x. Okay, you change the x here to 1 over x. Okay, so you will get the graph straight line and it will pass through the origin. So what is the relationship for this graph? So for B, okay, the graph is directly proportional. Okay, the graph is directly proportional with x. Okay, so remember, let's say the graph is like this, okay, and you know this one is inversely proportional. So, and then you change the x-axis, okay, 1 over x. Because let's say the x is 4. So when you change to 1 over x is 1 divided by 4. Then you plot the graph. Okay, so, and then the graph will change to a straight line graph. Okay, and you must pass through the origin. So we get the answer is y is directly proportional with x. Okay, only this kind of graph that can transform to the straight line of graph, right? Okay, so this one is actually on your textbook. Okay, so there is something that I need to add for this one. Okay, for the in this PowerPoint slide. Okay, so this one actually I already teach you how to find the relationship, also the gradient. Okay, and then the area under the graph. Okay, I think you remember on in form 3, right? Okay, they give you a graph. Okay, they give you a graph. Okay, I think the graph is x here. The Hooke's law. The Hooke's law. Okay, the Hooke's law graph. Okay, and then if you want to find the elastic potential energy, you need to find the area under the graph. Okay, sometimes if you draw the graph, okay, the area under the graph can represent in some physical quantity. So let's say for this graph, the physical quantity that we can find is elastic potential energy. Okay, based from the from area under the graph. Okay, but not all the graph. Okay, some of the graph. Okay, not all of the graph. Okay, all right. And then next thing is the interpolation. So this one I will teach you in the tutorial that I give you the exercise. Okay, I will teach you how to do the interpolation and also extrapolation. Okay, so for this one I will teach in the tutorial that I already give to you. Okay, and then for your homework, so this is the exercise. Okay, I want you to do this one. Okay, the first one is a type of graph. So whether it's a curved line or straight line graph, and then you have to interpret the graph. Okay, whether what is the relationship of the graph. So example, like the first one is a directly proportional. So like this one, what is the relationship? Okay, and then the type of graph, whether it's a curve or straight line. Okay, only that's you need to do for these five questions. Okay, for these 5 questions. Okay, so any problem? Teacher, what is inversely proportional? Inversely proportional, this is the graph for the inversely proportional. Inversely proportional means the relationship of the graph. Okay, so let's say I give you one example. P is 1 over A. This is a pressure, right? And then this is the area. So when the pressure increase, the area will be decreased. So you can see the graph is inversely proportional. Okay, it's opposite. If the P increase, A decrease. If the P decrease, A increase. Is it okay, Vicky? Is Vicky here? Because I see. Okay. Any more question you want to ask teacher before I go to the tutorial? And make sure you have a long ruler, pencils. Do we have to take the attendance? Yes, I actually have to take the attendance. Yes, it's a proof that you attend my class. I already take your attendance. Let me show you. One second. I already take. Don't worry. Okay, so can we move on to the next one? Okay, for this part. Okay, if you have the questions paper, you can take it out. Okay, so let's say for the question number 1, right? So a student carries out an experiment to investigate the relationship between the increase of temperature. Okay, so I want you to underline the relationship between the increase of temperature theta and the mass of water m. So underline that sentence first, okay, because in that sentence they will give you the manipulated variable and also the responding variable. Okay, and also the responding variable. Okay, and then a heater is immersed in water and the switch is on. After 4 minutes, the maximum temperature theta 1 is recorded. Okay, so diagram 1.2 shows the initial temperature of theta 0. Okay, so means theta 0 is the temperature of water before you heat the water. Okay, alright, so let's read the initial temperature first. So this one is 30°C. Okay, and remember in physics unit is very important. So whenever you calculate something or you read any value, okay, using the measuring tool, so make sure you have the unit here. Okay, 30°C. Okay, all right, then after that we heat the water, okay, and give you the reading. Okay, so you have to read the thermometer here. Okay, alright, so for this one is theta 1. Theta 1 is 34. Okay, so you put here 34. Okay, so this is theta 1. Okay, it already state diagram 1.3 shows the maximum temperature. Theta 1 for M is 0.1 kg. So you read the thermometer here and you put it as a theta 1 reading here, 34. Okay, so how about theta? So actually in the question paper, they will give you all the formula that you need to know. So you can see here theta is what? Theta is theta 1 minus theta 0. Okay, so theta 1 we already read the value that is 34, right? And theta 0 is 30. So 34 minus 30 you will get 4°C. So this one is actually 1 over m, right? Okay, so 1 divided by 0.1, you will get 10. Okay, you will get 10. Okay, so for 0.2 until 0.5, I want you to read, okay, on your own and tell me when you're finished. Okay, try to read on your own. I give you example already, one example. Okay, I will call random people to give an answer for each diagram.
Teacher,
Yes.
how to calculate 10 kg minus 1?
10 kg minus 1. I cannot hear you clearly. What 10 kg minus 1? How do I get?
Uh, how do I get 10 kg minus 1?
Okay. So, in your paper, it wrote 1 over m, is it? Because this one I changed to Word from PDF, the symbol is changed. This is 1 over m, right? Okay, so here it gives you m is 0.1. So m is 0.1. So you just substitute m with 0.1. So 1 divided by 0.1, you will get 10 kg negative 1. Is it clear?
Clear, teacher.
Alright, thank you. You must really understand for this tutorial, because actually this one is a paper 3 for KBSM. Okay, before this is a written practical, right? Okay, but yours the different is the format is almost same, but the thing is you have to do the experiment. This one the reading is already give to you, right? And then you just draw a graph, okay, and you make analysis, find gradient, okay. But for in your SPM, okay, this one is you have to find on your own all the reading, but you still have to draw a graph, you still have to find the relationship of the graph, you still have to find the gradient. It's same, okay, it's the same, but the only difference, this one is already give the reading, you don't need to do the experiment. But yours, you have to do the experiment, and based from your own reading, you have to draw the graph. Okay, so later I will teach you how to draw a graph. Okay, so that's why I say you must really understand about this paper. Teacher, so basically the teacher, the what is to find the difference between the initial or the theta. Theta is to find the difference between initial temperature and final temperature, right? Okay, for theta 0 is the initial temperature. Okay, but theta 1 is the difference between initial and final. Yes, correct. Don't worry, the formula will be given to you. Okay, it's a very simple experiment. Okay, for the start, because yours is just new, right? So I think maybe like next year is your SPM. Okay, so maybe like 3, 4 years, they will not give you very hard experiment, just a basic one. Okay. Okay. Are you finished? If you are finished, can I call anyone? Okay, to give me an answer. For those who just join physics class, because I know some of you changed class, right? Can you text me later? Okay. First, I want to know how many that I need to photocopy for chapter 1. You still have to have the notes for chapter 1. Okay. Please text me later. Okay. Are you done? Yes, teacher. Right. Very good. Okay. So can I call Julius Lee Winyan? If you cannot open your mic, maybe you can just give your answer in chat. Julius Lee Winyan. No? 5 kg. -1. Very good. See, when teacher want to ask questions, everyone left the class. 38. Yes, 38. Correct. Okay, how about the theta? 8. Okay, very good. Okay. So this is actually can consider as your PVD. Okay. All right. Good. Okay. Next one. I would like to call Ng Kai Ting. Ng Kai Ting. Ng Kai Ting. Can just give your answer in chat. It doesn't matter. Ng Kai Ting. Teacher, not really understand the first one. Okay. That's why you should ask, right? Okay. So, this one I use this diagram 1.3 as example, right? Okay, so m is 0.1. Okay, and then here is 1 over m. Okay, this one is actually 1 over m. Okay, the symbol change because I convert from PDF. Okay, the symbol all change to like this. Okay, so 1 over m. So here you can see the value of m is 0.1. Okay, so m here I substitute it with 0.1. Okay, so you use your calculator, 1 divided by 0.1, you will get 10. Okay, Kai-Ting, are you clear about 1 over m? Okay. Alright. So how about theta 1? Okay. So theta 1 is the maximum temperature. So means you have to read from the diagram here. So here you can see is 34, right? 1, 30, 31, 32, 32, 33, 34. So theta 1 is 34. Okay, how about theta? So theta is actually the change of temperature. So you already read here is 34, right? Okay, so 34 minus with the initial temperature is 30 here. Okay, so 34 minus 30, you get 4 degree Celsius. Are you okay? I think. Yes, so can you do for this one? 3. This one is 3. Okay, you calculate using your calculator, what did you get actually? 1 divided by 0.3, right? So you got 3.33. Wait, I got my calculator first. Where's the calculator? Wait. Okay. Okay, so 1 divided by 0.3. You got like this, right? 3.3333333, right? Okay, so if like this, you have to take 2 decimal point. So 2 decimal point is what? This is the first decimal point, this is second decimal point. So take until 2 decimal points. So it will be 3.33. 3.33. Okay, are you clear? I think 3.33. Alright. So and then how about the theta 1? What's the reading for theta 1 here? If you cannot see it clearly, I will make it bigger for you. So this one is 42. Yes, very good. 42. Then how about the theta? Theta is the change of temperature. Yes, 12. Okay, right. Okay, thank you for your response. Okay, as you can see here, starting from this reading, you already got for 1 over m, you already got 2 decimal points, right? Starting from diagram 1.5, you already got for 1 over m is 2 decimal points. So, means for every diagram, 1 over m, you have to put 2 decimal points. So, for this one, you have to put 10.00, 5.00, okay? Right, and then this one already. So, all of the reading here, for 1 over m, you have to put 2 decimal points. Okay, because for this one, you already start to take 2 decimal points. Okay, anyone clear? Everyone clear about that? This one is very important. Okay, the decimal point must be same. Okay, So you start from 2 decimal points. So all of this you must put 2 decimal point, even if there's no value for it. Teacher, is it a must to put 2 decimal point? Okay. Whether you have to put 2 or 3. The minimum is 2. You can take 3 decimal point also can. Okay. It's a must. Must. Okay. Right. So 2 or 3, but usually we only take 2. Because if you take 3 decimal point, it's very hard for you to plot it on the graph. Right. 3 decimal point is too small. Okay. So 2 or 3. Okay. The minimum is 2. Okay. Is it clear? Any question? You should ask, okay, before, because after this we have one experiment you have to do, okay, and you have to submit me the report, okay, and we have mark for it. So you have to understand really how actually you want to draw a table, how you want to give me the reading, all that. Teacher must put decimal point behind the whole number also. Yes. Okay, because it must be uniform. Okay, it's like 2 decimal point, then all of the reading must be 2 decimal point, but only for 1 over m. For this one, for the temperature, no need. Only for 1 over m. Okay, even there is no value for it. Okay, like 5.00 is actually same as 5, right? Okay, but in physics, you have to put it. Okay, any questions? You can ask now. All right. Okay, let's say if I have question, just type. Okay, I will see the question later, right? Alright, and then this one, 1 divided by 0.4. Okay, so I think this one you get 1 divided by 0.4. You get 2.5, right? Okay, 2.5. Okay, is it correct? Yes, 2.5. Okay, and then how about the theta 1? Theta 1 is 46. Okay, 46. Okay, and then how about the theta? Theta is 46 minus 30 is 16. Okay, very good. Okay, then how about this one? See, put, okay, put 2 decimal point. Okay, and next one, 1 divided by 0.5. So you will get 2. So 2.00. Okay, very good. Right, and then this one, theta 1 is 50, right? So 50 minus 50. And this one, 50 minus 30 is 20. Yes, very good. Okay, so ready? Okay, complete the diagram. Okay, and then now let's see for the next question. So it said for the experiment described on page 2, identify the manipulated variable and also the responding. Okay, actually remember that I already asked you to underline the sentence. Okay, the relationship between the increase of temperature and the mass of water. So between these two variables, so one of it must be manipulated variable. So anyone can try which one is a manipulated and which one is a responding. Okay, very good. The mass of the water is manipulated. Mass of water, yes. Okay. Alright, but maybe some of you confused, right? Which one is the manipulated variable and which one is the responding variable? So you can see from the diagram here, okay? From the diagram here, what's the question give you value? So it give you the value of m. For every diagram, they give you the value of m. So means the m is actually the manipulated variable. So m is what? M is a mass of water. Okay, let's say if you are confused, okay, you can see in the diagram, right, what is the value given by the question. So the question give you the value of m, right? For every diagram, they give you value of m. M0.1, M0.2, right? So means the manipulated variable is the mass of water. So you put here mass of water. Okay. So how about the responding? Yes, very good. Okay, so means the other one must be the responding variable. So increasing in temperature. Okay, increasing in temperature or increase of temperature. Okay, and then next one is the constant variable. So constant variable, first one, let me remind you, cannot use the measuring tool. So what is the measuring tool here is the thermometer. So cannot put the type of thermometer. Cannot. Okay. Type of what? Cannot use the word type of. Okay. Don't use the word type of. Type of water. Type of beaker. Cannot. Okay. Beaker also is a measuring tool. So cannot. Okay. So what is the constant variable here? Anyone has idea what is the constant variable here? Okay, let's see for the on the diagram given the apparatus. Okay, so here what you think that can be the, yes, very good. Okay, power supply. Okay, so means you cannot put the power supply. So means you have, that must be a physical quantity. So what is the physical quantity that given by the power supply? So the power supply is heat the emission heater, right? So mean heat supply by the heat supply, okay, by the emission heater. Temperature of a teacher roti. Okay, sorry. There's someone, they come to sell the roti. The read using the bike. Okay, so and then another one, it can be initial temperature of the water. Okay, so mean you have to make the initial temperature of the water should be a constant variable. Okay, but remember, if they want you to put one answer, just put one answer. Okay, don't give two. If you give two, means you ask the teacher to choose which one they answer. Okay, so cannot. Only one answer, one question, one answer. Let's say if asked two, then you give two. Okay. Okay, so this is the how you want to find the variable. Okay, for B, I think we already done. Okay, record, calculate 1 over M. Okay, this one also already done. Okay, and then tabulate your result for M, 1 over M, theta 1 and theta. So you can see there is a 4 value that you need to put in table. So you draw a table here. Okay, draw a table. Okay, 4 column because 4 value, right? So put the table. You have to draw with ruler, okay? Alright. And then you put all the title M, 1 over M, theta 1, theta. Alright. So it's not finished yet, okay? You must have a symbol and unit. So M, the unit is already on the diagram given to you. M is in kg. Okay, so kg. 1 over M is kg negative 1. Okay, theta 1 is in degrees Celsius and this one is also in degrees Celsius. Okay, so after that you copy back all the value in the diagram. Okay, just copy back all the value. Let's say I give you one example. M is, the first one is 0.1, right? Okay, and then 1 over M is 10. Okay, theta 1 is 4. Sorry, 34, right? Okay, and then theta is 4. Okay, just put like that. No need to put the unit anymore. Okay, but this one, don't forget, this one is 10.00, right? So put it 2 decimal point. So this one, the column, you already start with 2 decimal points. So all the column must be in 2 decimal point. This one we already start in 1 decimal point. So all of it must be 1 decimal point. But let's say you have a 2 decimal point, you have to put 2 decimal point. So all is 1. Okay. Picture in the, oh, okay. Teacher, why do we need to divide the mass with 1? 1 over m. Okay, because actually we want to get the graph. Okay, for y over m, actually the graph should be like this. Okay, this is graph for 1 over m. Okay, so but for this one, if you draw m, you will get straight line like this. Actually, how to say, why we need to 1 over m? Okay, because we want to show that m is when 1 over m theta, right? This, hmm, wait, m is theta is increase, m is maybe this. 1 over m we have to divide because actually in paper 3, right? They just ask you to draw any graph, okay? To to test your how do I say? To test whether you can draw if 1 over m a graph or and how about m over theta graph like that. Okay, so they can ask you just to draw any random graph. Okay, actually this one we basically know lah. If the mass increase, the theta is decreased, right? Okay, when you if you add more water, okay, you add more water means the temperature will decrease or wait, mass increase. Yes. Okay, can see here. Let's see the reading first. As you increase the mass, the theta here is increase. Yes, the theta here is increase because it take a longer time, right, to read the temperature. So means that every 4 minutes, this one for the first 4 minutes, you take this one, you will get 34. And then you add more water, then you wait for 4 minutes, okay, you will get this value. Okay, and then you wait for we get you add you add more water, okay, and then you wait 4 more minutes, okay, and then the temperature will be increase like this. It's just to show you that you add a certain amount, okay, with a constant value, okay, the temperature increasing also will be increasing constantly. Okay, so actually is they can ask you to draw any graph. Okay. Are you done already? Okay. Now you have to draw a graph. So this is the graph. Okay, I already draw the axis here. Okay, no, for the graph, for physics graph, there is no negative axis that you need to draw because it means all is in the positive, okay, positive axis. Okay, so means you can draw like this. Okay, all right, and then the first one is you have to put the title for the graph. Okay, for the x-axis, you know already the title is m ag. Okay, and for this one is theta degree Celsius. Okay, theta degree Celsius, and this is m over kg. Alright. Okay, and then next one you have to choose the scale. So the scale here is 1 to 5 only. So what does it mean by 1 to 5? Okay, so you can choose, you can put like this 1. Okay, use a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or you can put 2, 4, 6, 8, uh, 10, 12, 14, 16, 18, or you can put 5, 10, 15, 20, 25, 30, okay, like that. Or you can put 0.1 also, 0.1, 0.2, 0.3, 0.4, 0.5, or you can put 0.2, 0.4, 0.5, okay, 0.6, right? Okay, so you can only use this scale, okay? And for this, for the x-axis also the same, or you can use 10 also. Okay. 1, 2, 5, 10. Okay. So only this four scale is allowed. Okay. Other than that, no. Okay. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, okay, and so on. Or 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, okay, so on like that. Okay. So same as x-axis. Okay, so for this one, you have to see your reading first. Okay, for the x-axis, the maximum value is what? You have to see your reading first. For the x-axis is m, right? So 0.1, 0.2, 0. Until 0.5. Okay, so what is the scale that we should put here? So this one I will teach you first. Okay, so this is 0.1, 0.2, 0.3, 0.4, and 0.5. Okay, so this is the scale for the x-axis. Okay, so how about the y-axis? So y-axis is the increasing in temperature, right? So increase in temperature, the maximum is 20, right? Okay, and then the lowest one is 4. Okay, so what scale that can be used for the y-axis? Any example? Teacher, how do we know that what does the axis represent? Okay, good question. Good question, good questions. No, we are not using that one. If you're using that one, you cannot get the straight line graph. You will get this line graph. I already done with 4M and 4K. It will be like this. I don't want the graph like this. I want to be a straight line graph. Okay, and then you can see actually the question is wrong because here, right, here they ask you to draw theta against m, then later they ask you to state the relationship theta and m. Okay, so I don't want like that. Later you have to choose to draw two graph, so just straight away theta against m. If you don't draw a graph, then you cannot know the relationship, so just draw theta against m. Even if you draw theta against 1 over m, your graph should be like this. This is a curved graph. I don't want you to draw a curved graph. Okay? Alright, how do we know that what does the axis represent? Okay. So on the graph paper on page 7, draw a graph theta against m. So theta here is y. Okay? And then here should be x axis. Okay, good question, we can. Okay, right. So we use this one. Okay. You can draw theta against y of 1 over n. Okay, is you can draw, but you will get the inversely proportional. The graph will be like this. Okay, and I already told you in exam that we will not asking you about the curve graph, right? And it's hard for you to make an analysis, and it's not make sense if you ask people to draw theta against 1 over m, but later you ask people to find the relationship between theta against m. So the question must be something wrong here. Okay. So we just use 1 over m because I want you to draw a straight line. Okay, are you clear? Eugene? Alright, very good. Okay, now we go to the next part. Okay, and then for the y-axis, I ask you to choose the scale. So what scale that you should use? 1, 2, 5, 10, 0.2, 0.1, or 0.5, or 0.1? Any answer? 2. So means 2, 4, 6. Is it? Is it enough? Okay. Zian said 2. So let's try. Okay. So 2, 4, 6, 8, 10, 12, 14, 16, okay, and then 18, 20. Right, very good. It's enough. Okay, and to draw a graph, okay, you must use the graph at least 50% from the graph paper. 50% from the graph paper. Okay, so if you use the scale 10, 10, 20, then finish already. So that graph is wrong. Okay, the bigger the graph is better. Okay, alright, and then next step you have to plot it. Okay, so I think you already know how to plot the graph. Okay, so the first one you're reading is 10, sorry, 0.1, right? So 0.1 is 4. Am I correct? Okay, 0.1 is 4. So you plot the graph here. Make sure you use this mark. Don't use the point dot dot cannot like that. No. Do not draw like this. Okay, use this mark. Okay, 0.2 is 8. Okay, and then 0.3 is 12. Okay, and then 0.4 is 16. And the last 0.5 is 20. Okay, like this. Right? So after that, you have to underline. Okay, you have to underline. Okay. Underline, use ruler. Cannot freehand. No freehand. Okay, must underline with ruler. And must use the long ruler. If you use a short ruler, then after that you will move your ruler, right, on this side because the line is not enough. Then your graph will be double line. Double line is a wrong graph. Okay, cannot. Okay, cannot. Okay, so you have to draw smooth line, and also your pencil must be sharp. Okay, must be sharp. So for me, okay, my opinion, better you use a mechanical pencil. Okay, mechanical pencil. Right, it must be a sharp, okay, and straight line. Teacher, must pass through origin? Doesn't matter as long your graph is balanced. Okay, teacher, the graph pencil, no pen. No, 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 no. If we use pen. Okay, just use pencil. All this must in pencil. Okay, all this must be pencil. Okay, so underline. Okay, doesn't matter if writing also the numbers. Alright, the numbers is okay, you can write in pen. But later if it's wrong, you want to change the scale. How? You use liquid. Ah, better you use pencil because later they say you use wrong scale, right? So then you use liquid, then you will, the graph is um, not so neat. Okay, just use pencil, it's okay. Okay, so you underline it. Okay, so teacher will underline it. Where is it? Okay. Wait. Suppose you can pass through all the line, right? It just yeah, like this. Like that. But mine is thicker because if I put in very small, the thin line, you will not see the line. So my graph is like that. You can see it doesn't matter to, whether it's passed through the origin or not. as long the graph is balanced. Okay. Right, we finish draw a graph. Okay. So alright, next thing. Alright, when I mark 4M and 4K graph, I noticed some of them they didn't underline until intercept any axis, whether y or x. Okay, so your graph must intercept axis, whether x or y. Okay, cannot hanging graph that no. Okay, you will use mark for the relationship. Okay, so based from my graph, okay, for my graph, okay, let's see the next question asking you to find the relationship. So the relationship is mine is not passed through the origin, right? It's not passed through the origin. Okay, so if not passed through the origin means it's increasing linearly. Okay, so theta is increasing linearly with x. With with x with m. Okay, increasing linearly with m. If pass through the origin, then you can use directly proportional. Never ever say when the theta increase, m also increase. I'm sure later some of you will use this one as a relationship. No, increasing is as in physics is hypothesis. Okay, for the conclusion or relationship of the graph, you can only use increasing linearly, directly proportional, decreasing linearly, inversely proportional. That's all. Okay, the one that we learned before, the relationship of the graph, how to interpret the graph, only that can be used to describe the relationship between theta and m. Other than that, cannot. Okay, so yes, teacher. If the line didn't touch the origin, also never mind. Yes, never mind. Okay, never mind. Okay, not all the graph that can touch the origin. Okay, but there's something that you need to know. There's not all the time when you draw a graph, you can use all the point to underline. As long it cuts through one of the axes, right? Yes. Okay. Okay. There's a sometime when you draw a graph, not all the point that you can pass through. Okay. So, but for this one, it pass through, so it's okay. So let's say if you draw a graph, yeah, I show you example. So let's say the graph is like this. Okay. So you underline. Okay. There are 2 points here. Okay. This graph is right. Okay. Why? Is correct. Okay. Why? Okay, because the two line here, okay, at the above part of the graph and one part, 1 point under the graph, it's still considered correct. Let's say you try to find, okay, cannot pass through all the cannot pass through all, okay, but only can pass through 2 point like this, okay, but they have 2 point on at the above part of the graph and 1 point below the part of the graph. So this one is considered correct as long the graph here, the point between the distance between the point and also the graph that you underline not more or equals to 0.5 cm. So mean you have to measure. After you underline, you measure the point. Okay, whether it's more or exactly 1.0 exactly 0.5 or less than 0.5. If less or exactly 0.5, it's still acceptable. Okay, or like this also okay. Can never mind. When I just want to know about I just want to tell you about the point. Doesn't matter uh where the graph okay intercept whether x, whether y, whether it's directly proportional. It doesn't matter as long you have to see the point. Okay, all right. And then next one, let's say like this. Okay, okay. So like this. Okay, this is 2 point here and 1 point here. Okay, okay, doesn't matter where the point is as long one is above or two at the below part of the graph. Okay, so still the same, the concept must not more than 0.4 or is 0.5 or is equals to 0.5. Okay, this is also considered correct. Or can be like this. Okay, one here and one here. Okay, and the graph is less or equals to 0.5. Okay, the distance between the point and the graph that you underline is uh, equal or is equal or smaller than 0.5. This is also considered correct. Okay, are you clear? Are you clear? Teacher, can it be 1 point from down, 1 point down and 2 points up? Yes, can. 2, 1. As long 2, 1, 2 on the top, 1 at the below part. Doesn't matter. And doesn't matter where they intersect. Don't worry about where we intersect. Is this? No. Doesn't matter. Don't think about that one. Okay, when you underline the graph, the important thing, see the point. Not, it doesn't matter where it will intersect. See the point. Which one? There must be balance. Okay, or two at the above and one at the below part, or one at the above or two at the below part, or one at the above and one at the below part. And then you have to measure the distance. Okay, so you measure a distance. Okay, maybe I can make it bigger like this. Okay, let's say here. So here 0.5 cm or less. Okay. Any questions? Any question you want to ask? No, teacher. Okay. So since no questions, so what I want you to do, okay? This one because I already draw for you, right? Later I will give you one more graph. Okay, you have to do from the first part, okay, until the last one, until here, until the relationship. Okay, so you have to do from A until E. Okay, and then you snap the photo and you send it back to me, okay, at Google Classroom. Okay, so if anything you still don't understand about the graph, you can ask teacher. Okay, so we stop here. So next class I will continue number 2. So this one you will learn how to extrapolate, okay, or interpolation here. Okay, I will teach you. Okay, so I think we stop until here, right? Thank you, class. Okay, see you on Thursday, I think. Right? Okay, bye bye.
Thank you, teacher.
Okay, welcome. Bye.
Thank you, teacher.
Welcome. Welcome.